Hi, my name is Katie Mock. I'm an assistant professor in the chemistry department, and this fall I taught Chemistry 121, also known as Introductory Chemistry, and needed to adapt this class for HyFlex teaching. So I'm going to talk about what I did in the class differently from before and what came out of it. So first, I want to start by talking about exactly what the course looked like before COVID. So I had taught this course once before with John Hofferberth. Together, we structured Chem 121 into a fully flipped classroom model. So what this meant was time in class was spent on challenge problems where students worked in pairs. The instructor and the lead tutor would circle about the room and provide guidance and answer questions as needed. Time outside of class was spent reading the textbook, but also watching instructor prepared content videos, which were taught in a pen tablet style for the most part. And then students were asked to complete a class preparation assignment, or CPA, the night before, and this would foster exposure to the new material that we would talk about and work with in the next class. And they were able to communicate any content questions that they had as well. Exams were administered traditionally. They were timed in-person exams for a 50-minute class period, Monday, Wednesday, Friday. And we would also have weekly short quizzes that were intended as review each Friday. So these were 5 to 10-minute quizzes and just a couple of questions, and they were peer graded by using a notebook that they would take notes in and also do their quizzes. I'll note that I wanted to be very careful about how I adapted this for HyFlex because we teach a wide range of students in the chemistry department in Chem 121. We have many biology majors, neuroscience majors, students of physics, environmental studies, and some students who are trying to meet their NAT/PSI or QR distribution. So there's a wide swath of interest and level of experience with chemistry before coming into the classroom. And most of them are first and second year students. So this is one of the first points of contact that they have with the chemistry department, but also for many of our first years, one of their first classes in the science quad. I'm showing here the grade distribution of my class 121 second section in fall 2019. And you can see that there's sort of a range of grades and more than we would want down sort of in the C range. So let's talk about the perceived barriers for learning in Chem 121 due to COVID-19. So in this hybrid class, I had 11 fully remote students and 71 in-person students, and I needed to adapt this side-by-side pair work into the physically distanced classroom and think about how active learning and assessment can become more accessible and equitable for the students who are not present. And also think about how course content delivery can be made available to those students. So I'm also highlighting here the space restrictions I was under. I was teaching in Ross Hall Auditorium where we had no desks and my students were kind of in the dark of the auditorium and I couldn't really see their faces. And then the other section was in CAC 237. So a large room not built for having a class in it and difficult to get to know them, although better lit, so I knew them a little bit better by appearance. So my first plan to minimize perceived barriers was to strengthen the supplemental video content. And so I aim to have a supplemental video for every class topic unit. We started with 15 videos that had been created by myself and Professor Hofferberth. That was roughly half the course content. I wanted to make sure that all of the videos I was showing them were coming from Kenyan instructors. And so I paid the lead tutors to caption and upload those previous videos, as well as all the new videos that I created in the summer to add in all the topics that were missing so that there was at least one video supplement for every CPA, which we succeeded in doing. And I organized all of those in one location, whereas before they had been a little smattered about. So this is just showing an example and the technology that I needed to accomplish this that wouldn't have been possible without CIG support. The next thing was in-class content delivery, making this available by video. So I wanted to make it equitable for the remote students. And every in-person lecture, both the slides that I was delivering were being streamed over Zoom, as well as whiteboard via the iPad if needed, using a high quality microphone and a wide angle webcam to capture me as I move about in front of the projector screen. and also be able to pick up any questions from the audience. And every of these lectures was recorded. So I uploaded these to YouTube for captioning and then posted the same day to Moodle. And so this had the outcome of both students on and off campus actually would attend synchronously via Zoom at various times. Of course, the remote students always via Zoom. Students had lectures available then to review after class had passed. And so this also enabled several of my remote students to choose asynchronous study, which was better for their home situation. This required quite a setup that took about 10 minutes to set up prior to class, so that was a challenge. But with my tripod, my webcam, my microphone, and all of the software support, I was able to deliver this to students in a way that I think met them where they were. So then I needed to convert these challenge activities to being accessible remotely. And for this, I had two sort of strategies. One was to utilize interactive quizzing applications in order to engage students and assess their understanding in real time in the absence of being able to check in with them one-on-one during pair work. So I'm showing here an example of I would give them these challenge problems as worksheets that would give them space to write on, and they would turn those in at the end of class. And then those worksheets were tied to interactive polling so that students could see the question in multiple formats in case it was difficult to see from the back of the room, or if my slides weren't clear for a remote student, it just kind of gave them multiple points of access. And then I used Pear Deck as well as in-class worksheet collection to take attendance without using class time. And this allowed me to give sort of equal weight to remote and in-person attendance and engagement, despite the challenges of monitoring the chat, trying to get my lead tutors to help with that. But I think it wasn't as great as I wanted in order to get those remote students to be able to ask questions and participate. This at least gave them the opportunity to kind of play along, right? And then email me with questions later, or meet via office hours, or ask in the chat when possible. And to do this, I used Poll Everywhere and Pear Deck, depending on the class. Some examples are shown here. The second goal was to convert those daily pair work sessions into a weekly remote class. So this both minimized the amount of time that we had 40 people all in one space, just for safety reasons, and also allowed them to have face-to-face interaction with one another and with me without wearing masks, and be able to work through problems to still develop those problem-solving skills and their teamwork abilities. And I'm showing here some examples. So what these challenge problems looked like was a little bit different from before, but I would give them multi-part questions, between 5 and 7 questions per session. And then they could collaboratively work on the whiteboard in Zoom together with varying degrees of success, depending on whether they had a tablet or they were using the tablet substitute device. But the thing that I want to highlight, I guess, is that I use this ORID discussion facilitation technique, observation, reflection, interpretation, and decision or determination, to train them to think analytically and give them a framework to connect with one another and engage respectfully. So they would then upload an image of their collaborative work into their Google Doc or slides and save it in a Google folder that I could then review and make sure that I could keep track of all of the students who were working together, and then grade them just for coming and doing the work. And I could see that they had participated and engaged. And they usually would not complete these challenge questions, but it gave them some stuff for the exam. This is an example slide that they had, one of our first ones when I was still using Google Slides instead of Google Docs. So I asked them to put their names here, and then you would save it in the Google Classwork Drive. And here I explain the structure for the responses. I want them to first together observe the facts. So what do we know? What are we given? Then reflect, identify what other information you need to solve the problem and what you want to get at the end, and then interpret. Tell me the map of your steps to solve whatever you're going to use for your strategy. What's the progression to how you're going to get to your answer? And then determine, execute the steps and solve the problem. And I asked them to switch roles each time. So one person is writing and one person is calculating. And that way I was hoping it would make it more equitable. I also kind of gave them choose your own adventure. So for more advanced students, they could go on to the harder problems and start there, which might take more time. And for the students who felt like they were still struggling with the material that week, they could start at those green problems and move on as they felt comfortable. So here's an example problem. I asked them to type in these boxes what is known, what is needed, and then map the steps and then execute the solution. So here's some sample student work. They took what was known about the volume and the molarity, and then said what they needed, and then they mapped out, they kind of explained their reasoning, and then they used their tablet substitute device to write out what they were doing. So the final component that was a big change from fall 2019 was to have all OpenNote 24-hour take-home exams instead of in-person timed exams. And I thought of this as devising an assessment strategy that would equalize the remote and on-campus student experience, but it also ended up rebalancing the priorities in a way that I think improved equity to emphasize problem solving and application over the ability to memorize and do math quickly. And so what did this look like? I wrote very similar exams, almost identical to what I had written in fall 2019 with the same length. But on exam days, I made a PDF available on Moodle of the exam as written, starting at 6 a.m. because I had some students in very far away time zones. And I didn't hold synchronous class on those days. That allowed students the time to take that exam during that period if that was the only time that they had with their class schedule. And the completed exam was not due until the following day at noon. So they got actually a little bit over 24 hours, but with time zones and things like that, it kind of worked out. And this was OpenNote, all class resources available, videos, lectures, etc. But I prohibited peer collaboration because I really wanted them to go and find that information for themselves and write out their logical progression. And I required that logical progression and that reasoning for every single question. And I told them full credit would not be given otherwise. And I'm showing an example student exam here where I asked this question. And then even for something like a drawing, I wanted them to explain quickly what they were doing. And especially during a calculation, I want them to tell me how they're calculating, why they're doing it, and what they're ending up with at the end. And I got some really great work from students. And if they were doing poorly, then the exam took them longer, which was difficult for them. But if they had been studying and keeping up, then I found that they weren't too overwhelmed by the amount of time they had to take the exam. So pros and cons, I found it significantly easier to grade because I require them to give explicit reasoning and emphasize the logical progression so I could know what variables they were calculating, I could know why they were doing what they were doing. And I think this de-incentivized cheating because even if you're working with a peer, you still have to write out the reasoning. And so ultimately, you're going to think about how you're doing it and learn something from the exercise. I also think this really advantaged students who have a lot of test-taking anxiety or slower math speed in ways that I felt I was really happy with because I think that those students are just as capable, but they do more poorly when we have these timed rigid exams. And of course, then I could give flexibility to students in different time zones. I also saw many more extremely high scores on these exams. And although I felt like that was complicated, I did think that it meant that these students were really engaging heavily with the material, which is ultimately what leads to learning. So cons, some students spent way more time on the exam than I anticipated, using most of the 24 hours as they could, thinking of it as this take-home exam when I wrote it as a 1-hour exam to be taken during our class period. It was also a challenge to teach students how much reasoning I actually wanted. So some of them would write pages and pages, and that would take forever. But really, I just wanted very concise explanations. So that kind of was something that we had to build over the course of the semester with feedback. And the biggest question, I think, is, do students cheat when you give them this opportunity? I did have one AIB case at the end during the final exam, but I actually didn't notice any other obvious unauthorized collaboration throughout the semester. And it's not hard to notice when two people have an extremely wrong answer that's extremely wrong in the exact same way. So this isn't as easy if you get the right answer to tell who's cheating, but I didn't feel like there was a lot of cheating that was happening because I was requiring that reasoning. And so I saw some students do very poorly I think because of COVID and just kind of falling off and having a hard time accessing the course in this way, but I also had a lot of A's. So that was sort of a con where it was this different bimodal distribution of some of the exams. I want to show here comparing the exam grades for the midterms and the final exam between fall 2019 and fall 2020. As you can see, the grades are much higher, despite the fact that my exams were not really any different. But time was certainly an issue in fall 2019. And overall, the standard deviation, you can see gets slightly smaller, but not by much. But really, there's a sizable difference in terms of the average grade here. And then the final grades, we can compare those as well. So in 121 in 2019, the grades, it was a much smaller class. I had about 25 to 30 students. And on the right, you can see that there's a lot of A's, so it's really skewed. There was an extra credit opportunity going to Picture a Scientist and writing a reflection paper, which is why you see some above 100. I also had one incomplete and one withdraw late in 2020, which I think is not surprising during coronavirus. But you can see here that even with all of these sort of open note exams and all of these points for turning in the CPAs and the challenges, we still had some students who didn't do well. But the reason why we have so many A's is because if you did the work, then you were rewarded, which I felt good about in terms of what we want them to be doing during a pandemic. So I administered a pre and post survey written by Erica Farfan in her office. We saw a slight increase in belonging, where here blue is strongly agree, red somewhat agree. And we got, nobody said they strongly disagreed by December. We saw a big increase in the number of people who strongly agreed that they were comfortable asking me for help with understanding material and assignments. We also we have very few disagrees here. This one I think is fun. I find chemistry interesting and exciting. So we started out with, kind of not that many, but okay, we're at 40%, or we're at, maybe 50% agreeing. And now we've got the majority of the respondents agreeing either strongly or somewhat that they find chemistry interesting and exciting. We see an increase in self-confidence. I would say I can achieve understanding of difficult topics, even if they are confusing at first. So in September, it was, majority said that they agreed, but some strong disagrees. And by December, we saw an increase in the agrees in terms of being able to understand difficult topics, as well as an increase in resilience. So here, we increased the number of strongly agrees in terms of I can overcome setbacks to achieve my academic goals. And some of these strongly disagrees and somewhat disagree were gone from before. So that's what I used my CIG grant for. The technology support was completely, I would not have been able to do this without it. And so I'm super grateful to HHMI and the committee here at Kenyon for the support. And I'm happy to talk about any of these things with anyone who's interested. Thanks.